Okay, we are on page 491, lesson 9-3. I'm going to do problem number 2 as an example to recap what we did yesterday. The instructions for number 2 are to find any points of discontinuity and the function is x squared plus 2x over x squared plus 2. What is it that I need to do to find the points of discontinuity? What are points of discontinuity? Excuse me. What are points of discontinuity? Just tell me in your own words. Make what equal 0? The bottom. X values that make the denominator equal 0. We want to know what they are because we can't use them in the domain because we can't let the bottom equal 0. So to find out what they are, you set the bottom equal to 0. Okay, so tell me how to go about this. I'm going to subtract 2 from both sides. I have x squared equals negative 2. And then I need to take the square root of both sides. So x is equal to plus or minus the square root of negative 2. What kind of answer is that? Imaginary. And I'm dealing with the real numbers. So are there any real numbers that make the denominator 0? So this one, number 2, has none. No points of discontinuity. The only way that'll equal 0 is if the number's imaginary. So it's pretty easy. Let's do number 4. It says 6 minus 3x over x squared minus 5x plus 6. Autumn, I need to give you something at the end of class about trig. Don't let me forget. Okay. Find the points of discontinuity. So take this, set it equal to 0. What is it that I need to do next? What do y'all think? You can factor it. Okay. How does it factor? Okay. Why negative 3 and negative 2? They will multiply and give you positive 6 and add together and give you negative 5. Now set each of those equal to 0. And we get x equals 3 and x equals 2. So those are my points of discontinuity 2 and 3. That's all you're asked to do right now. When you get into college algebra, they're going to ask you for the domain. And the domain of this problem is everything from negative infinity all the way up to the number 2. But you can't use 2. So you have to kind of put the parenthesis on there. It tells people, hey, look, get as close as possible, but you can't use 2. In union with the section from 2 to 3, in union with the section from 3 to infinity. Okay? That's just bonus information, so you'll have it for next year. Now, all this problem asks you to do is find the points of discontinuity, but the next section of the lesson asks you to tell me whether these points of discontinuity were holes or vertical asymptotes. So we're going to go ahead and do it on this problem, but first you need to tell me, what is a hole? whole is a number that makes both the numerator, Numerator, and the denominator equal 0. What's a vertical asymptote? Number that only makes denominator 0. Okay? So the big group's called the points of discontinuity. Once you get in there, you're either a whole or a vertical asymptote. We have to figure out which one you are. So let's go back through here. Tell me about the number 2. Is the number 2 going to cause the numerator to equal 0 or something else? What happens when you put 2 in place of x? So that one makes the numerator 0, so number 2 is a whole. And then the next one, 3. If you put 3 in place of x, does it equal 0? No. So this one is a vertical asymptote. And that was yesterday's lesson. That was all we did yesterday. Okay, so I've done number 2 and I've done number 4. Let's do number 14. 14 asks you to describe the vertical asymptotes and the wholes for the graph of the rational function. It says y equals x squared minus 4 over x plus 2. So the very first thing we're going to do is find the points of discontinuity. Chanel, what's the points of discontinuity for this one? It's the x value that causes the denominator to... What do you think? Dalton, what's the point of discontinuity? Either one. You can tell me either one. Okay. How do I pick them out? Okay, when it makes the bottom equal 0, you're exactly right. So for this problem it'd be -2. Okay, let's talk about whether it's a whole or a vertical asymptote. Well, you got to talk about the numerator. Can you factor the numerator? Yeah. What would it be? Y'all agree with him? It's called the difference of squares. Y'all remember that? Okay. Would this -2 cause the numerator to be 0? Yeah, it would cause this one to be 0. And because you're multiplying 0 times, well, it doesn't matter what you're multiplying by. If you're multiplying by 0, it's going to be 0. So, but this causes both of them to be 0, so this is a whole. Now, why did I ask you to factor the numerator and the denominator? Because I want to write this function in the simplest form possible. Is there anything in the numerator and the denominator that they have in common? Right, but if you use it in both places, you get 0 times -4, which is 0, because you're multiplying. If it'll make one of your factors 0, it wipes the whole thing out. Is there anything in the numerator that it has in common with the denominator? And I want you to focus on this and this. X plus 2. So they will cancel. So my function is y equals x minus 2. Well, that is a linear. So this is what the graph would look like. Where would I start the graph? What's the y-intercept? Now over here, remember, x cannot be negative 2. So over here where x is negative 2, I'm going to have a hole in my line. This negative 2 is on the y-axis, so I don't want y'all to get them confused. This is when y is negative 2. Now, what's the slope of this line? So I'll go up 1 and over 1, and here's my line. And that's what it would look like. It would literally have a hole in it right there. Okay? Any questions on holes or vertical asymptotes or working with these functions? So far, so good? Okay, let's do 16. Y equals 9 minus x squared over x squared minus 9. What do you think? Can you factor the denominator? What would it factor into? Okay. So what are your points of discontinuity? 3 and negative 3. What about the numerator? Can you factor the numerator? You can? What does it factor into? Can I say 3 minus x and 3 plus x? Okay. So let's categorize these points of discontinuity. If you put 3 in place of the x, would it cause the numerator to equal 0? Yes, it would cause this to equal 0, and I don't care what you got over there, to equal 0. So that makes that one a whole. If you use negative 3 in place of the numerator, in place of x in the numerator, would it cause it to equal 0? So it's also a whole. Do you see anything they have in common? What do they have in common? Those, right? So I'm simplified down to 3 minus x over x minus 3. When this happens, you realize the numerator and the denominator are very closely related, right? Yes? Closer than normal. When this happens, I want you to factor out a negative 1, and I don't care which one you do. We're going to factor a negative 1 out of the top. We're going to take negative 1 out, and that's going to make that be negative 3 plus x. And I'm going to rewrite that as so these actually cancel, and I get y equals negative 1 as my graph. And I would come over here to about 3, and I'd have a hole. And I'd come over here to negative 3, and I'd have a hole. Anybody have a question? I know this is new stuff, but none of it's terribly difficult. Okay. So we've talked about points of discontinuity, and then we categorize them as holes or vertical asymptotes. Next, we need to talk about horizontal asymptotes. Horizontal asymptotes rely on the degree of the numerator and the denominator to decide whether one exists or what it actually is. So you're going to focus now on the degrees of these functions. Write this down. Category 1. If the degree of the denominator is greater than the degree of the numerator, the horizontal asymptote occurs at the line y equals 0. That's situation number 1. Situation number 2. If the degree of the denominator is equal to the degree of the numerator, then you have an asymptote at A over B. Now let me show you where A and B came from, okay? AX squared plus 3 over BX squared minus 5. A and B are the coefficients of the leading terms of these polynomials, okay? So let me give you an example. What's the degree of the numerator? Where do you look to find the degree? What do you think? Yes. There's 3 numbers up there. 2 of them are the same. What do you think the word degree means? It's the exponent. It's the highest exponent in the problem. So what's the highest exponent in the numerator? 2. What's the highest exponent in the denominator? 2. So that means the degree of the numerator and the denominator are equal. So what you do is you take their coefficients. What's the coefficient here? 1. And that is your horizontal asymptote. The line where y equals 2. Let me graph one real quick. Show what this picture looks like. Two x squared plus 5 divided by 1x squared plus 1. It never touches the line where y equals 2. The line where y equals 2 runs right about there. That's what we're talking about today, is horizontal asymptote. Okay? If the degree of the denominator is greater than the degree of the numerator, let me give you one of those. What's the degree of the numerator here? 1. What's the degree of the denominator? 2. So this means that this has a horizontal asymptote at y equals 0. Let's put that in the calculator and look at it. X plus 1 divided by 2x squared plus 3. I made it up. It's not perfect, but the horizontal axis is the asymptote here. Okay. What do you think what do you think about situation number 3? We've said the denominator was bigger than the numerator. We've said the denominator was equal to the numerator. What other situation have we not discussed? If the degree of the numerator is greater than the degree of the denominator, then it has no horizontal asymptote. Okay? And this would be an example. So horizontal asymptotes depend on the degree. So you did 1 through 18. I want you to do 496. 19 through 30. sketch the graph of the rational function. You'll have to use your calculator to do that. Then add 46, 47, 48, 49, 50.